Here with yet another video based on the topic pigeonhole principle. So this is one of the topic in the KTU syllabus of the 2019 scheme, pigeonhole principle. So here first we have to know that what is pigeonhole principle. Then based on that statement we have to do one or two examples. So here first topic is in mathematics the pigeonhole. The statement is I have taken a simple statement. In mathematics, the pigeonhole principle states that if m items are put into n containers with m is greater than n, then at least one container must contain more than one item. So here at least means here it denotes as greater than or equal to. So here at least denotes the simple greater than or equal to. So here first the pigeonhole statement is if m items are put into n containers with m is greater than n. So if it is given, suppose we can say an example. Suppose 10 items are there means or 10 birds are there or 10 pigeons are there. If you want to place it in 9 boxes means one will be extra. That means that one has to be accommodated in any one of the container which contains more than one bird. That is the concept here. That's what it is given here as pigeonhole principle. So here m items in general you can say that if m items are put into n containers with m greater than n, then at least one container must contain more than one item. That means here one thing is at least one container with m by n, that means seal m by n. This is the symbol here. With seal m by n, this is the symbol like this, seal m by n items. So seal means the greatest integer which is greater than or equal to x. Seal in computer science students will be learning about this. The greatest integer which is greater than or equal to x, that means a whole number which is above or nearest to that number, whole number which is nearest to the integer. So here next floor of there is another symbol which is floor. So seal and floor are this is floor symbol and this is seal symbol. So floor is the greatest integer which is less than or equal to x. For example, see floor of 9 by 5 is equal to the floor of 1.8. So which is the nearest integer. See here the nearest integer means we can say here the nearest integer means we say it as 2, but which is less than or equal to means less than or equal to the nearest integer. The smallest integer is 1. So the answer is 1. But the same answer, the seal of 9 by 5 means the seal of 1.8, that is equal to the greatest integer which is greater than or equal to x, the whole number above this value 1.8, the next whole number is 2. So we can take it as answer. See here one or two examples also there. If the floor of seal of 8.1 means the nearest whole number is 9. Floor of seal of 12.01 means it is also the whole number is 13. Floor of 3.8 means the value is also 3. So the nearest integer or the integer which is less than or equal to x. So here the nearest integer means floor of 3.8 means the nearest integer is 4 but less than or equal to. So 3 and 4 are the two integers, in between is 3.8. So the nearest integer but which is less than means this is 3. If it is floor of the value means it is, that is floor of 3.8 is equal to 3. Seal of 3.8 is equal to 4. This is the concept, you have to know that. So at least one container with seal m by n items. So here there is a statement which is given as theorem also. You can learn this theorem also. If k is a positive integer and k plus 1 or more objects if k is a positive integer and k plus 1 or more objects are placed into k boxes, then there is at least one box containing 2 or more of the objects. You have to learn this statement. If k is a positive integer and k plus 1 or more objects are placed into k boxes, then there is at least one box containing 2 or more of the objects. Next one, we shall move on to the example. Suppose a department contained 13 professors, then 2 of the professors were born in the same month. So, same month it is given here. Suppose a department has 13 professors. We know that in an year it contains 12 months. In an year, 12 months are there. So, we shall take it as m equal to 13. So, always m should be greater than n. So, m is equal to 13 and n equal to 12. Therefore, m should be greater than n. That means 13, which is great. We are considering as 13 is greater than 2. Then at least 1 month. So that means one professor with sorry, here not container. So then at least there is more 1 month has 2 professors. How is it possible? So that the seal of m by n is equal to seal of 13 by 12, which is equal to the seal value of 1.083. The nearest integer, which is the greatest integer, is equal to 2. So therefore 1 month has 2 professors. So in this 2 professors are born in the same month. So therefore not more than 1 is considered here. So only 13 members are there. Each are born in one month, but one person is extra. So that person may be born either in any one of the month. So that we consider 1 month has only 1 month has 2 professors. So therefore we say this is applied here by pigeonhole principle. They are saying that. So this is considered, or this answer is cleared with by pigeonhole principle. The reason is by using pigeonhole principle they are considering the answer. So by pigeonhole principle we can say that at least 1 month is with 2 professors born on the same month. Now let us consider another example. Let us have 3 pigeons and 2 boxes. See, let us consider 3 pigeons to be A, B and C. So therefore 2 boxes let us consider to be 1 and 2. So and how will you consider this? And one of the pigeon has to be see here 3 pigeons has to be accommodated in 2 boxes. That means first pigeon we can accommodate in first box, second one B can be accommodated in the second box, but third there is no space. For the third pigeon there is no box. So therefore what we will do means by using the pigeonhole principle, we can say that one of the pigeon, that means the third pigeon, can be accommodated either with A or with respect to B. So that is the concept here. Nothing more calculations. So we can say this very easily. So let the pigeons A, B and C, and one of the pigeon has to be accommodated in any of the 2 boxes, which means that any one of the cell will occupy more than 1 pigeons. So here you can write the concept that by pigeonhole principle. The reason is by pigeonhole principle. You can write the reason here by using the pigeonhole principle. Write the reason here. That means the concept is m equal to 3 and n equal to 2 here. Therefore, m should be greater than n. That means the floor of this value, the seal of 3 by 2. Seal of 3 by 2 is 1.3. So therefore we can say that the value is 1.5. 3 divided by 2 is 3 divided by 2 1.5. So by pigeonhole principle we can say that m equal to 3, n equal to 2. Therefore 3 by 2 equal to the seal of 1.5. The nearest value is equal to 2. Therefore 1 container can be accommodated with 2 pigeons. So 2 pigeons has to be accommodated in one container. So that is given here, and one of the pigeon has to be accommodated in any of the two boxes, which means that any one of the cell will occupy more than one pigeon. Now there is another example. Suppose a laundry bag contains many red, white and blue stalks of socks. Then one need only to grab 4 socks to be sure of getting a pair with same color. So therefore laundry bag how many socks are there? So it contains red, white and blue. So therefore red, white and blue socks are there. Many socks are there. We need to take only 4 and sure of getting a pair with the same color. So there are 3 different colors. One is, what are the 3 different colors? Red, white and blue. 3 different colors, and also he has to take 4 socks. He has to take 3 varieties of socks. We are having more socks, 1 2 3 4 5 6 7 8, many is there. In a box it contains many. So therefore there are mainly 3 varieties of socks are there, red, white, blue, but we have to take 4 socks out of this. So m is equal to 4 and n is equal to, what will you take? We have to take it as n is to be the different colors. So how will you take that one of the socks has that means automatically you know that 4 socks when you take any one of the colors. So red, white, blue. So therefore one more if you want to select means that will be the repetition of any of these 3 colors. So suppose a laundry bag has 3 colors, 4 you have to select, one from red, one from white and one from blue you are selecting. And later on the concept is you have to select one more. If you want to select one more, then the next one, the last one will be the repetition of any of the 3 colors. So therefore you can say that m should be here always greater than n. So therefore m is equal to, let us take m equal to 4 and n equal to the 3 distinct colors. So n is the color, 3 distinct colors. So therefore the m divided by n, that is equal to 4 by 3 is 1.33, which is equal to 2, which means that there will be a pair of socks with the same color. Next example. Among any group of 367 people, there must be at least 2 with the same birthday, because there are at least only 366 possible birthdays. So therefore we are having 367. So 367 people, which means that they are distinct. So these are all distinct cases, because this much person represent that they are distinct. So we can't say that one is a repetition, one person is a repetition of the other. So among any group, and also in this 367 persons are considered, there must be at least 2 with the same birthday, it is considered. So by which concept they are using this? So because there are at least 366 birthdays. So there is a possibility such that we can take it as n is equal to, let n is equal to 366. So let us take m equal to 367. So here always m is greater than n. So therefore m divided by n, that is the seal of m divided by n, is equal to 367 divided by 366. And that is equal to, what is the answer? So the answer is seal of 1.0027. That is equal to, the seal value is equal to 2. So therefore we can say that seal means the nearest value, which means that there is at least 2 persons, there is at least 2 persons with same birthday. They are celebrating their birthday with two persons, all the others are celebrating. So 367 people, they are distinct, and there is a possibility such that there is at least two with the same birthday. So at least two persons with the same birthday, they are considered. So in one day, two persons are celebrating their birthday, all the others are many. So normally here 367. So by which concept we are considering this? That means by using the concept of pigeonhole principle, we can say that m by n, that is the seal of m by n, is equal to seal value of 1.0027, that is equal to 2 persons. So 2 persons are celebrating one day, same birthday. So they are celebrating. This is the method we have to consider. So therefore there is no calculations and all, just we can write this, from this part the questions will be from part A. The next one is, see here, there is another example. In a group of 27 English words, there must be at least 2 that begin with the same letters. So there, because there are 26 alphabets in the English. So how will you consider this? This is also, you can say that m is equal to 27 and n equal to 26. So therefore we can say that by using the pigeonhole principle, you can say that seal of m by n. So by using the pigeonhole principle, we can say seal of m by n is equal to seal of 27 divided by 26, that is equal to one seal of 1.038, that is equal to 2. So therefore we can say that here there are 27 English words and there must be at least 2 that begin with the same letters. So therefore two English words begins to, all the other words are distinct, but only one is repeating. So another one is repeating means that one repeats any of the say English letter. So it repeats any of the repetition is allowed here. So therefore here we can say that by using pigeonhole principle, 2 English words. So there are 26 alphabets. In this 26 alphabets, 2 English words begin with same letter. So therefore 2 English words begin with same letters. Now the next question, how many students must be in a class to guarantee that at least 2 students receive the same score on the final exam if the exam is graded on a scale from 0 to 100 points? So how will you say that? Since the exam is graded from 0 to 100 points, that means that how many possibilities are there, how many students are there? We want to know that how many students are there in a class. So therefore they are giving a hint that there is at least means greater than or equal to 2 students receive same score. 2 students are receiving the same score, which means that all the students are graded with from 0 to 100. 0 to 100 means also here how many possibilities are here? 0 to 100 is there, which means that we have 101 possibilities. So we are having 101. When you count this also, there are 101 possibilities. So therefore we can say that by using pigeonhole principle, it shows that among any 102 students, that means how many number of students possibility is there? So here from 0 to 100 means how many possibilities, how many points are there. That means there are 101 possible score. So therefore by using pigeonhole principle they are saying that if it is 101, more than 101 there is a possibility that with at least two is having two students having the same score. So two students are having same score means it shows that among 102 students, which means that their number of students is equal to 102. There must be at least two students with the same score, that is 102 divided by 101. That means by using pigeonhole principle we are considering the seal value of m by n, that is equal to 1.099, that is equal to 2 students. So therefore two students are having how many possibilities? They are having same grade. Therefore the number of students is equal to the total number of students. Therefore you have to write the total number of students, that is equal to how much the number of students will be greater than the possible score. So therefore it is equal to 102. Therefore the total number of students is equal to 102. Next.